Welcome back to math class and welcome to 10-2. Today we're going to talk about what it means to simplify radical expressions. Just hopefully you remember from yesterday what a radical expression is, but it's basically a function with a square root symbol in it. You remember that from yesterday. Y equals the square root of x. First thing we're going to talk about when simplifying them is something called the product property of square roots. The product property basically states that if I have the square root of a times b, we can rewrite that as the square root of a times the square root of b. So to put numbers in there, if I had, say I had the square root of 16, we know that that's 4, right? But I can rewrite 16 as 4 times 4, right? And I could rewrite this as the square root of, or the square root of 4 times the square root of 4. Now the square root of 4 is 2, so this square root of 4 is 2. So I can rewrite that even as 2 times 2, which is 4. Now you know off the top of your head that the square root of 16 is 4 probably. So you don't have to rewrite it that way. But what happens if I have a more complicated problem like the square root of 180? We don't know that one off the top of our head, so we're going to split 180 up under its square root symbol into its factors. When I do that, I'm going to get 2 times 2 times 3 times 3 times 5. That's 180 split up into all of its factors. Now when I split it up into its factors, what I see right off the bat is I have 2 squared, right, and 3 squared inside of it. So I can rewrite this as the square root of 2 squared times 3 squared times 5. Now using the product property, what I showed you where I can split it up, I can split that up as the square root of 2 squared times the square root of 3 squared times the square root of 5. This is helpful because I know that the square root of 2 squared is just 2, right? So I can say 2 times 3 times the square root of 5. 2 times 3 is 6, so we end up with 6 on the square root of 5. And that is our answer to the problem. The square root of 180 can be simplified down to 6 times the square root of 5. That's where we're going to leave them today. We're just trying to simplify them, not find their exact values. One other thing, this is just with numbers, but what happens when I plug in variables? Let me erase this. Okay, so suppose I had this time a bigger one, the square root of 32 r squared k to the 4th t to the 5th, right? So I'm going to do the same thing though as I did with the 180, where I'm going to split this up into its factors so that I can find the pieces that we can take out, or we can find perfect squares of. So when I split this up, what I'm actually going to do is I'm going to split 32 into 2 times 16 because we know that 16 is a perfect square, right? So I'm going to do the square root, splitting it into its factors, of 16 times 2 times r squared is a perfect square, so I'm going to leave that r squared times k to the fourth, so I'm going to split k to the fourth into k squared times k squared. And then t to the fifth, I'm going to split up into t squared times t squared times t. Okay, that's a really long thing now, but I've split it up into factors that I can find the square roots of. Now that I've done that, I'm going to split them using our product property. And we get that this equals whatever the square root of 16 is times the square root of 2 times the square root of r squared times the square root of k squared times the square root of k squared times the square root of t squared times the square root of t squared times the square root of t. Again, it's pretty long, but now we can start simplifying it piece by piece. The square root of 16 we know is 4. The square root of 2 we can't simplify anymore, so we're going to leave it as the square root of 2. The square root of r squared will give us r. The square root of k squared will give us k. Square root of k squared again is k. T squared. Square root of t squared is just t. Square root of t squared is still just t. And the square root of t over there is what we have left. Now I'm going to combine my like terms. So I'm going to start by putting 4, then r, 2 k's left, so k squared, 2 t's on the outside of the radical, t squared, and then we have the square root of 2 and the square root of t left over. So it's going to become the square root of 2 times t, right? Okay, so once we've simplified all of it out, this simplifying the square root of 32 r squared k to the fourth t to the fifth equals 4 r k squared t squared on the square root of 2t. There's a lot of steps. We just do one step at a time, simplifying one piece at a time, and you can get there. One other thing I think is probably good to mention, what I did here at the end when I was grouping them, I didn't write it on here, but when I put them all together and I had the square root of the square root of 2 times the square root of t at the end, I just did the same process with the product property backwards to combine them into the same radical. Because the square root of something times the square root of something equals the square root of those things multiplied together. I'm still doing the product property, I just did it backwards right there. Okay, that's one way to simplify expressions, is with the product property of square roots. We're going to learn one more thing about simplifying square roots, and it is called, instead of being the product property, product means multiply, right? Instead of product, we're doing the quotient property. Whoops. Quotient. So when you think product, think multiply. Quotient, we think divide, right? So what happens if I have the square root of something being divided by something else? If that's the case, It's really similar to the product property in that the square root of a divided by b equals the square root of a divided by the square root of b. We can break it up just like we did with the multiplication. One thing that's really important about this, though, is when we're simplifying these expressions, we can't leave a radical in our denominator. That's not how we just can't leave it like that. So let's try an example and I'll show you how we get rid of the radical that's in our denominator. Remember, the denominator is the underneath of the fraction, the thing we're dividing by. So suppose I had the square root of 6y over 12. And I asked you to simplify this. What you're going to do is, using our quotient property that we just learned, you're going to say, I know that the square root of 6y divided by 12 is the same as saying the square root of 6y over the square root of 12. But I'm not finished there because I can't keep this square root symbol in my denominator. I can't leave it there. So how do I get rid of it? Here's what we're going to do. I am going to take, since I have the square root of 12 on the bottom, the thing that's going to make the square root symbol go away is if the 12 is squared, right? So I need to multiply the bottom also by the square root of 12. But since I can't just multiply 1/2 of this equation by something, I'm actually going to multiply it by the square root of 12 divided by the square root of 12, because any number divided by itself is 1, right? So the square root of 12 divided by the square root of 12 is just 1. So I'm not changing the value of this fraction by multiplying it by this. I'm just changing what it looks like. Because I'm multiplying it by 1, and anything times 1 is itself. So I'm not changing the value, I'm just changing how it looks, so that we won't have our radical in our denominator. Okay, so when we're multiplying fractions, you guys remember we just multiply across the top and across the bottom. So this gets us the square root of 6y times the square root of 12 over the square root of 12 times the square root of 12. Now, that's going to, as we multiply it out, using our product property that we learned a second ago, I'm going to get the square root of 12 times 6y over the square root of 12 squared. 12 times 12. Now the square root of 12 squared, the square root cancels out the square. So I get, which will give us just 12 as our denominator, because those will cancel each other out. Now we just need to finish simplifying our numerator. To do that, let's go ahead and spread this out into its factors to see if we have anything we can pull out. So we're going to have the square root of 12 can be split into 3 and 4. So I'm going to split 3 times 4. And I'm going to split 6 into 3 times 2. And then we have times y at the end. Now we know that the square root of 4 is 2, and we have 2 3's in there. I'm going to rewrite it over here where I have more room, but just hopefully don't get confused. Okay, so I have the square root of 3 times 4 times 3 times 2 times y. All of that is over 12 right now. Okay, I'm going to keep going over here because I ran out of room. Now 3 times 3 will be 3 squared, so we want to group those together and get the square root of 3 squared times the square root of 4 times our 2 and our y that are left over, the square root of 2y, all over 12. We've grouped together the things that can be perfect squares. I'm going to take that, and the square root of 3 squared is 3, the square root of 4 is 2, and we still have 2y over 12. 3 times 2 is 6 on the square root of 2y over 12. But it's still not simplified all the way because I have a 6 and a 12 here, and both of those can be divided by 6. So I'm going to get the square root of 2y over 12 divided by 6, which is 2. I know that was a lot of math for just simplifying this. And all of that comes from, we can't leave this radical in the denominator. So as you go through your homework, you're going to see a problem like this. If you're tempted to just break it up like this, note to yourself, you can't leave it with this radical here. We're going to multiply it by something that equals 1, and then we're going to simplify it down using the product property that we learned earlier. If you have any questions about this, feel free to reach out.